Hello, my name is Gerhard Adam, and in this module we will take a look at defining the data sets that we are going to use within a JCL step. In particular, we're going to be looking at the parameters and what is necessary for us to be able to code up DD statements. So, just like we saw in our previous JCL examples, you can see that the DD statement follows the same basic format as we saw for our job and execute statement. We begin with a // identifying it as a JCL statement. We have a name that we use. We have a DD indicating the operation field, and then we have our various set of parameters that can be coded to define that particular DD statement. So the very first thing, of course, is to take a look at the DD name itself. Now, unlike the other names, which are subject to installation standards, the DD name has a unique requirement in that it must match the name that a program is expecting. As a result, the DD name itself, again, must be a unique name between 1 and 8 characters long. However, it will be defined by the program, meaning that either program documentation or knowledge of the program itself is required in order to be able to know what the DD name must be and what it represents to that particular program. So the name again can be alphanumeric using national characters, and then of course the names themselves, as we said, are going to be established by the program itself. What this explicitly means is that you cannot know what the DD name should be unless you have the documentation indicating what's required by the program. This is not something that you can simply make up. If the name is omitted, then depending on the structure of the JCL statement you're looking at, it would be considered a concatenation, which means that it is appended onto the previous JCL statement so that it's treated as if it's a single data set, even though several data sets may be referred to. And we'll see a specific example of that a little bit later in this module. In the event that you code DD names that are not required by the program, then they will not do any harm to the execution provided that the required DD statements exist. However, they will be processed for syntax, and they will be processed based on what the JCL statements themselves indicate. However, they do not play a role if the program does not reference them in any way. So again, we need to make sure that we are reviewing program documentation. In the case of IBM utility programs or programs that may be provided by a vendor, this documentation would be provided in the manuals associated with those programs. In the event of a user-written program, you must find out from the programmer what the DD name requirements are for the JCL. Here's an example of what I'm referring to when I talk about the relationship to the program. At the beginning, you can see that there's an entry in the program, and this is showing an assembler language program that specifically identifies the file that the program is going to process. And one of the parameters that is coded within the program is the DD name itself. In this case, it's file DD. That becomes the name then that we must specify in our JCL to establish that logical connection back to the program. Within the JCL statement, we would point to the actual data set that is going to be processed, which is then going to be assigned by the system. And in that way, what ends up happening is that between the program, the JCL, and the final allocation, we now have a link between the program and the physical data set that is to be processed. Here's an example of looking at the program code itself and how it would be referenced in the JCL. And we can see the DD names that are defined within the program, and we can see those same references then in the JCL that is being used to execute that particular job. So there is a one-for-one correspondence that has to exist so that any DD statement that is defined within the program must be accounted for in the JCL. If it's not, the program attempts to process that particular file, you will have a failure in the program with a missing DD statement. So the input and output data sets then They can reside in various media. They could be on disk, they could be on tape. That's certainly one way of doing it. We could have output that is destined for a printer, in which case it will be written to an output queue. We may also have input that is actually in line with the JCL, which would represent like card images, for example, that we might submit as input data. This is often done as a way of passing control statements or commands to a program. So very often you will find that commands in that fashion are passed as inline data as part of the JCL. So a couple of different things we need to consider in terms of the way I/O files are being handled. One, we can specify a file as being a dummy, or a dataset name equals null file. Both of these indicate an empty dataset. In other words, we have a DD statement that we have to account for, but we either don't have any data or we don't want to use it in any processing. We can designate it as a dummy file, which will cause it to immediately reach end of file if the program attempts to read anything from it, so it will be treated as an empty data set. If it's defined as an output data set, then all of the output written to that will be automatically thrown away. It will not be collected anywhere. And so the idea of a dummy DD statement is nothing more than to null a file, whether it be input or output, so that it produces no results or creates no input for use within the program. This is often done in situations where we may want to test something, or where we may have a situation of where data is being produced, maybe output, and we don't really want to see the output because we're testing it, so we may just dummy that output out so that we don't collect anything. Similarly, we may have a situation of where we have input data, but not all the time. And so in which case, instead of specifying a data set name that is empty, we can simply specify it as a DD dummy, indicating that at least at this time, there is no input data.